Hello, my name is Abhinav Pavitran, and today I'm going to be presenting my project, leveraging transfer learning to enhance real-time emotion recognition. This is the brief index of contents that I'll be covering today. The introduction, just to give a brief overview and a reminder of what was said in the previous proposal. The aims and objectives to discuss what was achieved and the objectives that were completed, the outputs to show what was obtained and the software implemented. In the evaluation, I'll be talking about the differences in the project implementation as compared to the proposal, and the references contain all the relevant information that was searched. So, introduction. Emotions can be described as a sort of bodily sensation or behavior that we experience or feel in response to a particular event or a situation. And facial expression recognition is a very popular field of research in computer science. The two popular approaches are machine learning and convolutional neural networks. But one of the drawbacks to convolutional neural networks or CNNs is training the network from scratch, which is quite computationally expensive, time consuming, and it requires a lot of data. So to solve this, a transfer learning approach is implemented. Aims and objectives. So in the proposal, some of the aims that were discussed was choosing the right pre-trained models. So the pre-trained models that was chosen for the implementation were VGG16, VGG19, Inception v3, and Exception. These models were then fine-tuned and tested, and various datasets were analyzed, researched, such as EffectNet and FER 2013 plus. EffectNet was the preferred dataset. The model also had to be generalized, which means the model should be able to perform over a variety of scenarios, but due to the lack of dataset access to EffectNet, and all the backup dataset or the alternate dataset had to be used, which is FER 2013 plus. So the additional models that were added, that is Inception, V3, and Exception, I'll just quickly glance over them here. Inception V3 consists of 42 layers and 24 million trainable parameters, and it has two interesting aspects to it, which is factorized convolutions, where to make the convolutions more efficient and quicker, the larger convolutions are broken up into smaller convolutions. And another one is grid size reduction. Usually max pooling or average pooling is used to reduce the grid size, but this network efficiently reduces reduces the grid size using network filters. The next one is Exception. It consists of 71 layers, but 22 million trainable parameters only. And some key aspects of it is modified depthwise separation. For example, if there are 5 channels, then it'll have 5 and cross-end spatial convolutions, making it quicker and more efficient. And the final few layers will have pointwise convolution to help change or reduce the dimensions. Now to talk about the output. So all 4 models were developed and tested. However, the model had some difficulty being generalized due to the nature of the dataset, as the dataset, to describe it in brief, was a 48 by 48 resolution as opposed to the EffectNet resolution of 224 by 224. And the images were black and white as compared to the RGB images in EffectNet. And the pre-trained models were usually trained on RGB data, so the model had some difficulty adapting to this varied data set. But however, the models were still able to train well under the given circumstances, and VGG16 performed the best with about 62% accuracy on the test data. VGG19 had about 60.2, Inception V3 had 50.8, and Exception had 59.7% accuracy. The software was developed in about 2 stages. So in the first stage, the models were developed, trained, and tested on the Paperspace platform. Then the camera feed, and then in the second stage, it was implemented on a local machine, that's my laptop, on VS Code. The camera feed from the laptop was used to analyze emotion in real time using myself as a test subject. So in the feed, a bounding box is placed around the detected phase with emotion displayed above the bounding box along with the confidence value. VGG16 was ultimately chosen as it had the best accuracy, and also during real-time emotion recognition, the model was quite stable. So it didn't change or waver too much during the detection phase. We can observe this quick video of myself testing the model, the VGG model. It has a fairly easy time detecting some of the more popular emotions such as neutral, surprise, happiness. But you can see here that it has a bit of a tough time sorting out between sadness and fear. This is maybe due to a couple of reasons, but I believe it's mainly due to the data set and the imbalance in the data set. But something that I would like to emphasize on also is that there was data augmentation techniques applied to the data set to kind of even out the balance, but data augmentation only goes so far since you're all working with images just transformed in certain ways. So this section, I will just talk about some of the differences between the implementation and what was proposed initially. The preferred dataset, that is AffectNet, was not granted access to, so the backup dataset had to be used. AlexNet was replaced with Inception v3, and two additional models were also added. Only one emotional model could be tested. In the proposal, I have talked about two main models, which were Ekman's Ekman's model of 7 basic emotions and the Valence arousal model. But in the FER 2013 plus dataset, it only contains labels for the 7 basic emotions, so the Valence arousal version of it could not be tested. Also, another important aspect that was changed in this project and in the implementation was the number of layers unlocked for the models. In the proposal, I had said that maybe only 3 to 4 layers in the only the first initial 3 to 4 layers of the models would be unlocked and trained. But however, during the training phase, I discovered that it was not capturing details and not giving a good accuracy as a result. So in VGG16, about 10 layers were unlocked, and VGG19 the same number. And in Exception and Inception, around 12 to 15 layers were unlocked, so the model could train better. These are some of the references that was used to implement the project and do the research. That is all. Thank you.